So thanks for joining our Geek Chat. This is the second one of these we've done. And before we kind of get into a little bit of logistics, maybe we'll just take a minute to have everybody introduce themselves. My name is Dan Siemon. I'm one of the co-founders of Preseem. A little tiny bit of history. I've worked with internet providers basically my whole career, from very small ones to being product manager at a networking company for really big ones. And of course, now with Preseem focused on local and regional providers. So very happy to be talking about Bufferbloat today, and in general, anything related to internet providers. So with that, I'll pass it over to Jeremy and Brandon.
Hey guys, my name is Jeremy Davis, and I've been working in this industry for about 20 years now. I'm currently with WISP.net, working as an integration engineer and helping our customers get on our solutions. Like Dan, I'm very much looking forward to this opportunity. Bufferbloat's one of those things that are not really discussed very often, and it'll be good to provide you guys with some solutions on how to handle it.
So my name is Brandon. I've been in the industry for about 10 years now. Also an integration specialist with WISP and a WISP consultant on the side as well. Hopefully everyone gets a lot of great information from our Geek Talk today, and we'll get things started. Thanks, Dan, for having us.
Awesome. So it was just a little kind of reminder for everybody that this is the second one of these that we've done. What we're trying to do here is something very different than a normal webinar, where kind of each person has a block of slides, they talk for a while, and there's questions at the end. We're trying to make this more ad hoc, a little more unplanned, a little more, hopefully a little more fun, and just kind of see where things go. So that the goal of this is we pick a topic, we throw some discussion ideas on a slide like this, and we just kind of start and we see where we end up. We've cheated a little tiny bit because some of the things we might go into can be aided by some pictures. So we have a few pictures we might jump to on the slides, but this is really meant to not be a slideshow. So we do not have a lot of slides, and we're just going to kind of talk. So maybe with that, if we want to start, if you guys want to just talk for a second about at a high level, like what Bufferbloat causes in the network, the symptoms, what people would experience, subscribers, and it's really not just related to WISP networks in any way, like any network, and then maybe that'll help people build a bit of an intuition as to what they've seen in the past that matches this, and then we'll kind of wrap it back around to what Bufferbloat actually is and what's happening at the lower levels and what you can do to fix it.
Sure. So some of the things you're going to see when you are experiencing buffer bloat is an increase in latency. That's the number one thing you're going to see, with an addition of that jitter and a degradation of throughput. So you're going to see problems more in your real-time applications like VoIP, customer gaming, those things that require real-time communications. It's going to be difficult when you're experiencing buffer bloat. So some of the feels you're going to feel as an ISP operator: increased phone calls, particularly on a particular segment of the network.
Cool. Brandon, anything to add?
No, I think Jeremy covered it pretty well there. As you said, one of the biggest complaints that I get as being in the industry as an operator and a consultant is a lot of complaints about voice over IP and gaming. Not necessarily the common symptom of people thinking buffering is just video buffering on video streaming platforms. That it is definitely a symptom, but it's not the main symptom.
Yeah, actually, that's a good point. I didn't think about that. Like, we're not talking about video buffering. We're talking about packet buffering in the network causing problems. It's like a night and day difference in terms of where that problem exists. This isn't the Netflix spinner saying buffering at all, for sure. Cool. So the way I like to think about it is if you've ever, I'm sure everybody's had this experience where you have a network link that's working really well, customers are happy, you're happy in your home at like 80% usage, maybe 90% usage, and it goes from 90 to 95, and all of a sudden everything is not 5% worse, it's like 1,000 times worse. And all of that is really the result of buffer bloat. It's a result of buffers that aren't managed properly. That's not fundamental to a packet network. Like if you have good buffering control, you can run a link at almost 100%, and you're not going to feel that nastiness. So if kind of the way I got involved in this a long time back was my home internet connection. I noticed that if I was doing big uploads or even big downloads, latency would be really high. So I'd be, ping the internet, and you'd get 100 milliseconds of latency to the next hop. Well, that DSLAM, in that case, DSL time, it's not far enough away that the speed of light to get there is adding 100 milliseconds. Like, something else is doing it, And that all turned out to be essentially, in that case, buffer bloat in like the CPE equipment in my house. So that's kind of how I ended up going down this 10-year rat hole of figuring out and how to managing and dealing with buffer bloat.
And buffer bloat can happen anywhere on your network. It can be happening at your core, or it could be happening at the client's location if they're throttled down to a specific amount and they're trying to do more than what their router or package can handle. They could be experiencing buffer bloat there as well. Yeah,
so buffer bloat, to make that a little more precise, like it can happen anywhere that there's packets can queue. So every network path is going to have one spot, which is the slowest point in the path, and that's the path that's the point where buffer bloat is going to happen for sure. Sorry, go ahead, Jeremy.
Oh, one of the locations I commonly see this when I was running a WISP, a few years back, was at the access point level. So you've got a congested access point, everybody's suffering. We have this idea that the best thing we can do is try to push the largest amount of throughput through an access point. But in reality, capping that access point off, 5 or 10 megs less than it can actually push will reduce these situations from happening.
Mm-hmm.
Go ahead. Sorry, go ahead, Dan.
No, you go.
Oh, I was going to say, it could also happen if you're not seeing maximum throughput on an access point. It could be due to signal degradation as well, but that's another problem.
Yeah, that's kind of the problem that causes the packets to queue in the first place, which then causes the Bufferbloat symptoms. Yeah. So if you guys had that experience too, where let's take an access point, for example, like everybody's pretty happy, no one's complaining, and then just a little bit more bandwidth, a little bit more load, and now all of a sudden everybody's angry.
Oh, absolutely. We experienced a lot of that on our LTE network, which already probably has a little higher latency than normal, like 5 gigahertz networks that we're accustomed to running. And, you add that one customer and it's the straw that breaks the camel's back, and there has to be a threshold somewhere, It's usually that one customer that does it.
Yeah, exactly.
It's typically that one customer that does it, and it's the one customer or two customers that have the best signal that are complaining. And you have to kind of go back and review everyone on the access point, because it could just be caused by one person taking up too many time slots on the network.
Yep. Yeah. So let's kind of pop down a level then to what's actually happening. So I mean, I can do a little bit of history. We can all kind of riff on this, right? But this term buffer bloat started around 2010 from Jim Geddes. He's the guy that actually created the X11 Windows system. So if you use like Linux desktop, you've used his stuff. He's known for a whole bunch of other things. And we have some resources we'll send out afterwards, a couple of links that I dug up. And he's got an interesting story of how he kind of figured this out. And essentially what happened is he was telecommuting, and he was seeing really high latencies, and realized like there's no way this can be propagation like speed of light. Like the building I'm telecommuting to is across town, and started to really dig in it. And being someone with a lot of contacts, he had conversations with lots of very well-known people, lots of people high up in Comcast, who was his internet provider, and eventually kind of settled on buffer bloat as the term of what's happening here. And it's kind of something that was known in the networking research community, but didn't really get known in the, I guess we'll call it the practitioner community until Bufferbloat had a catchy name. It's kind of like, it's an example of when you name something, all of a sudden it matters. And that's really where this kind of started around 2010. A little bit, I guess, history of how what's happening here is we can jump to some pictures in a second too, but essentially it's at a bottleneck link when you have a lot of packets queued up, and that ends up adding latency for every packet because they're all waiting behind the other ones. And the reason this wasn't a problem 10 years ago is because memory was expensive. So people didn't put a lot of buffering in their CPE devices or in their access points, and et cetera. But over the last 10, 15 years, memory's gotten really cheap, and networking vendors didn't really stop to think about whether they should allocate all that memory to packet buffers. So the buffers just got bigger and bigger and bigger as the chips got bigger. And this has kind of grown into being a problem over time, just kind of through lack of focus on latency, really. Like a lot of times vendors are focused on one thing: how fast can I push a single TCP flow across the network? If that's your metric, you want giant buffers. It's the only way you accomplish it. But if you actually care about latency, like you'll see if you go to speedtest.net and fast.com now, they test for latency. If you care about that, you actually don't want big buffers for all the reasons you guys just kind of touched on earlier. So go ahead.
One of the things I know you kind of mentioned the difference between like the research and the practitioner community. This is definitely not a new problem. There's people that have actually dated the research back to like 1985 of these original problems coming up. But I think it's also the increase of what we call broadband. We never, previous to 10 years ago, we weren't really selling these huge, large packages to customers or even businesses. Businesses were still running on T1s and things like that. There was less opportunity to get a speed mismatch somewhere on your network to produce this. But now we're having WISPs that are selling 100 meg packages, and the problem's just getting worse with the demand of broadband these days.
Mm-hmm. Yeah. So what you said there is actually kind of key, like the mismatch. This happens when you're going from a fast link to a slow link. Wherever that bottleneck is, that's where buffer bloat can happen. And that's certainly like, downstepping from a busy 100 gig or 1 gig port to a 100 meg port, or on the AP from a 1 gig port down to whatever the AP can deliver, or in your house, like from whatever that is, the home Wi-Fi. Like every one of those points is where that can happen. But in some sense, the bigger the pipe, it's not true it's less of a problem, but in some sense it is, because if you've got a bigger pipe, you can get packets out the other side faster, so you're not going to get as much latency. So it's really a function of the ratio of the buffering to what the output link rate is. That is ultimately kind of what does that. So so from there, we can go. I'm happy to kind of dig more into like some of the lower level stuff, but it really just comes down to buffers that are too big. The packets are coming in. If it's too many packets stored, every one of those ones that's sitting out front, like at the front of the first in, first out queue, they have to be transmitted first. And if there's too many there, you get high latency. And maybe I'll just use that as an opportunity to jump to one slide just to kind of explain that a little bit. Like, I feel like a lot of times people don't really think about how long it takes to put bits on the wire. So like if you take this very simple of example, if you have a 1 megabit link and 1500 byte packets, it takes 12 milliseconds to write the bits to the wire. It's not instant. Like we tend to think of like writing a packet to the network is instant. Like it's just not what happens. So in this case, this is an example of obviously a slow link. It's 1 megabit per second, and there's 7 slots in the buffer going up the top there. If each one of them is a 1500 byte packet, it's going to take 84 milliseconds before that last red one gets out the other side. And if that last red one is a DNS lookup that's important for a web browsing experience, that's where you get the kind of pathologies of buffer bloat. So what have you guys, obviously we have our own thoughts on mitigating this, but what have you done in the past, even outside of the WISP space? Like I know for myself, when I was first playing with this a long time ago, I shaped my upload rate to stay below the bottleneck link rate to make sure that when I was doing uploads, my experience was good at home. What have you guys done in the past?
Yeah, something very similar to that. And that works really great when you're talking about one connection. When you're talking about lots of customers on an access point, and the access point is where you're having the difference in available bandwidths, then it doesn't work as well to be able to just isolate it to one to your router.
Yeah.
Now they do have some products on the internet that do some dynamic queuing. I think there's like Router IQ is one of them that produces like a consumer-based router that is supposed to help with this. You're looking at a product that's a little bit more expensive than the average customer, the average WISP is using for a managed router program. But those are things that you can use to mitigate it on a per connection basis.
Obviously, there's an upload basis, basically, because you can only mitigate it in the direction you're transmitting.
Correct.
So the CPU in the home can definitely help on the upload, but it can't really help much in the download, because by the time they get the packets, the AP's already had its problem.
Exactly.
Yeah.
Yeah,
Sorry.
I think
go ahead, I kind of cut you off. Yeah, go ahead.
Where I've seen problems in my personal network before I was really deep into IT, I think I was switching from, long story short, I was switching from an Android phone to an Apple phone, and I had to upload a bunch of pictures to the cloud in order to have them on my phone. and it was doing it in the background, and I had no idea that it was doing it. And I was like, why is the internet going so slow? I have coming in, but I'm doing a speed test, but I'm only getting 2 or 3 megs. And well, it's because my upload speed was being crushed by Apple trying to push this huge photo library up to the cloud. And I only had 1.5 meg up, but I have 100 down. So it was just being crushed by the upload speed, not being able to get the DNS requests out because of the buffer.
Right. And if the buffer wasn't so deep, you might not even have thought to run a speed test because your web browsing still would have worked. Which is kind of the key thing there. Just to pause for 1 second, we're streaming live on YouTube now as well. So if you want to go, you can probably find us there. I assume if you're listening now, you probably are going to stick with the webinar. But anyways, it's there if that's useful to you. So yeah, definitely. Like it's a lot of times the Bufferbloat causes the problems that encourage people to run speed tests. And if they just had a decent experience all the time, they'd never bother to run the speed test.
Yeah.
Cool. And that's a really good example. That's kind of the same thing like 10 years ago when I was mucking with this stuff at the start. Is that upload link becomes a real problem if it's not managed properly or managed in some fashion anyway.
Mm-hmm. And another common instance I'll get calls is torrent uploads. Someone's kid in the house is uploading a torrent file that they had no idea how to mitigate the torrent uploads or shape it so where that each user isn't able to take the maximum speed of any connection so that they wouldn't have that buffer bloat.
You're also seeing a lot of situations where now we have a lot of content creators in the world. People are streaming, video games or, just even just talking or webinars. Exactly, exactly what we're doing right now. These are prime examples of small things that can be done on the client end, but once again, that's only like half the puzzle, as you alluded to earlier. You still have your download that you have to handle and be able to handle buffer bloat from that end as well.
Good. So yes, I mean, back to kind of that concept of the bottleneck link. Like ultimately, there's kind of 2 ways to solve this. You either stay below the bottleneck link rate so the queue doesn't build, or wherever the bottleneck is, you do something smarter than a simple first in, first out. And that's kind of where, where we focused is moving that bottleneck kind of back to where you can do something a little bit smarter and do the, the active queue management techniques and stuff to solve the problem there, rather than having to necessarily keep the absolute rate below the what would be the bottleneck bandwidth at every individual hop. But it's really that's the 2 ways to mitigate. You stay below the bottleneck rate, or you do something smarter at the point of bottleneck. That's pretty much all you can do to deal with this. Well, other than replace all your equipment that doesn't have crappy buffers. But I mean, frankly, you can't buy most equipment that doesn't have crappy buffer management. So that's just kind of a reality. Okay, so sorry, go ahead.
Oh, Dan, do you think that maybe that's some pressure on vendors to be able to show like speed tests and their equipment on like unsaturated links? Do you think that's where that's coming from?
Absolutely. A lot of buffer bloat happened because networking vendors are focused on one thing: throughput. The only thing they measure their equipment against is throughput. So if I can run my whatever, back in the day when 1 gig was a lot, if I could run it at a full 1 gig, it's doing its job. But in order to run at really high rates with a single TCP flow, you need a lot of buffering. And it's just fundamental to how TCP works. And that unfortunately goes against what you want if you optimize for latency. So maybe one of the best things that came out of all of the buffer bloat, hype's not the right word because it's real, but the buffer bloat like mission and stuff, is the speed tests have added latency tests. That wasn't true before buffer bloat was well known. So you run fast.com, you run speed test now, it tells you what your loaded latency is. And that's the ultimate measure of buffer bloat.
Absolutely. Maybe we should start having our vendors like, what's the jitter on this link when it's at capacity? Maybe some of these are questions that we should start getting from our vendors, to get a realistic expectation of what it's going to work like in real world environments.
Yeah, it would be great if, as an industry, we didn't just demand throughput, we demanded latency, like good latency, and that's just not the reality for most testing.
Yeah, it's even harder for those in rural America relying on slow satellite internet or even just DSL.
Yeah, Yeah, when you have a small link and you're trying to keep it busy, if you have buffering on top of that problem, it's a million times worse. Like you can make a small link feel good with proper queue management, but if as long as there's a lot of buffering there, it's never going to be a happy situation. Like Netflix is going to just destroy everything else.
Yeah, but like you said earlier, a lot of the problem is hardware vendor related because they're trying to push the cheapest stuff out to the clients just to be able to keep up with demand.
Yeah.
And people don't want to spend a ton of money on hardware for their homes typically because they think that this says it'll do 500 megs. This should be fine for me when I've only got a 20 meg connection at home.
Yeah,
they don't understand the difference.
Yeah, and sadly, the cost isn't necessarily like a BOM cost issue. It's a software development issue to actually do smarter queuing in those cheap devices. Like a lot of them will have the processing. Well, the ASIC one's not so much because mitigating buffer bloat, if you're doing it in an ASIC, is a kind of a different problem. That's a fixed feature thing. But if it's a little more software based, it's really a software change. But if your customers, if you're a CPE vendor, your customer's not rating you on latency or not considering latency, it's not going to be optimized for. That's just kind of the reality, unfortunately, of how market dynamics work. So we lost Jeremy there for a second. I think, do we have Jeremy back now? Nope.
Yes, I'm back. Can you hear me?
We'll give Jeremy a minute to come back. So when you on the AP side, when you've seen these kind of things, Brandon, you end up doing some kind of shaping to the AP, or just when it's too busy, you just move some subscribers to another AP. Like what's how coarse and stuff is that?
So typically the latency issues that I've seen have been caused by one or two clients having really poor signal. And those aren't necessarily caused because they have the poor signal. They're taking up more time slots in the TDD framing to get the same number of packets that everybody else is, which is reducing the performance for everyone on that access point. That's the general problem I've seen in the smaller networks that I've been working with. And that's even more crucial when it comes to the LTE networks. So it looks like Jeremy's back now as well. But if I have a sector that has got 20 clients that all have fantastic signal and they're just hitting the peak of an access point's throughput, then I'm seeing the maximum throughput of that sector, and that's when I start seeing the buffer bloat.
Yeah, and I think you kind of hit on it there. Like those bad subscribers, you can kind of think of the wireless as like a shared bandwidth, right? So those bad subscribers are decreasing the amount of bandwidth there. So it's kind of just like it's a slower link. And once you have a slower link, going from a faster link to a slower link is, again, that's the point. You're going to have some form of buffer bloat if it's going to happen.
Right, but what also the operators out there also have to remember is like one bad link is not going to affect only the person with the bad link. It's going to affect everybody on that link.
Right. Yeah, because it nets down the whole throughput for the AP.
Correct.
Yeah, for sure. Do we have Jeremy back?
Yeah. Can you guys hear me?
Yeah.
Wonderful.
But he's not talking. So every meeting has IT problems. This is apparently going to be ours today, so that's okay. So maybe while we wait for Jeremy to come back, I'm just going to jump to a couple of things here. So one of the things that's kind of when I've explained this in the past to people, one of the topics that comes up is, well, why do we have to have buffers at all then, right? And unfortunately or fortunately, buffers are really, you have to have some amount of buffering in a packet network. They're just fundamental to how packet networks work. This little picture here to try to show why. So if you have a link and it's taking bits out of memory and writing them to the wire, that's kind of the orange thing flowing through the link there on the left-hand side. If you don't have a buffer and another packet comes in, you have to throw it on the floor. You have to just drop it, right? It's gone. That's the second column. And the problem with that is once you actually transmit that orange packet, the link goes idle. There's no more bits in memory to write to the link, and you end up wasting bandwidth. So every packet network has at least some amount of buffering to solve that problem. So the far right-hand side, there's a few packets waiting to be transmitted, and then that way there's never a time the link goes idle. So buffering is absolutely required. But what's happened is that it's gone crazy, where you get 1,000 packet deep queues and like crazy things like that. And that's really where you end up with the problem. So it's not that you shouldn't have buffers. Like, buffers are absolutely required. They just have to be managed properly. Okay, so we might have just lost Brandon too. So maybe the internet's having a bad day.
Can you hear me now, Dan?
Okay, well, they're gone. I'm gonna talk to a couple of more slides in there. We'll give them a chance to come back, and hopefully we can kind of reboot the conversation. The other thing that's super non-intuitive about buffer bloat is that it's actually made much worse by kind of how TCP works. So in that previous slide, I kind of showed the packets queued up, right? And where this happens the most is in interactions with TCP. So if you think about how TCP finds the bandwidth on a path, like there's no place in the internet where you can just, or no way in the internet to say, tell me the total amount of bandwidth between point A and point B. TCP probes and learns that dynamically. And it does that by increasing the bandwidth a little bit all the time, getting a loss, and then dropping the rate, increasing it a little bit over time, drop, blah, blah, blah. And you see the pattern there, that kind of familiar TCP sawtooth pattern. And what's maybe counterintuitive is it's not really measuring on a deep kind of networking level, network science level, whatever. It's not actually measuring the bandwidth on the path. It's measuring the ability of the path to hold packets. Some of those packets are like in photons moving between two fibers, two transceivers, but most of them are actually queued in buffers. So if you have really deep buffers, TCP kind of learns that, hey, this network can hold, 100 packets before it gets a loss. And then it sets its rate such that there's always 100 packets in flight. And this creates this kind of standing queue phenomenon. So what we're trying to show on the side there is this blue flow, which is maybe like a big Netflix download or something, right? Netflix stream. It's established this kind of standing queue where this queue has got a whole lot of blue packets all the time. But the other applications, that green packet, the orange packet, the red packet, they're stuck waiting behind that queue. And you can kind of think of that as bad queue. Like that, you need a queue for link utilization. But when you have this many packets in the queue, it's not accomplishing anything other than adding latency. And that's really where this gets nasty. You get this kind of interaction between TCP and big buffers to create really big latencies. And again, if you've ever done like a download and then done a ping at the same time, and you see that go up, the ping time goes up, that is not fundamental to the internet. That's bad buffering. I'm not sure if you guys are able to see it. The other guys are trying to join. I'm not really sure where the
Dan, can you hear me now?
Is at the moment, but we'll give them a minute. Hopefully we can get somewhere. So in the meantime, I guess I'll just kind of go through a couple more things here. So really the way to deal with buffer bloat is active queue management. So essentially do something smarter on the link than just a simple first in, first out or tail drop. So the left-hand column there, that's tail drop queue management. Essentially, if the queue is full, you drop the packet that's going to go into the queue. That's pretty much the worst thing you can do from a buffer bloat standpoint. But that's basically what's implemented on every router and every switch everywhere, and every CPE, et cetera. You could also do something a little bit smarter like head drop. And basically what that means is that you drop the packet at the front of the queue, not the new one coming in the back. And this is really counterintuitive because you think, well, I've spent all this time holding it. Why do I want to drop it? But the reason that's beneficial is because it means the loss signal will make it over to the end, to the receiver and back again faster. And that tells TCP to back off faster. So that ends up mitigating buffer bloat. We mentioned earlier that this is a known problem from a long way back. And one of the earlier techniques was red. So you've probably seen in your microtics and stuff, you can turn on red queue management, random early drop. Essentially, that algorithm is if the queue is full, randomly shoot a packet, essentially. This never really got deployed super widely because it requires a bunch of tweaking. And then the really cool thing that kind of came well after that, like up into 2012 now, came out after the buffer bloat work. After you name something, people care about it, it got a lot more attention. And the Codal algorithm is really cool. Essentially, what happens is you timestamp a packet as it enters the queue. And when it gets to the end, you look at that timestamp. And if it's over a threshold, you drop it. And the neat thing about this is it has the effect of dynamically sizing the queue so that you get good link utilization without building up a big backlog of queue. So that's kind of one of the fundamental things that came out of like network science, network research after buffer bloat was given a name. And then of course there's Been other really cool things come out of that. There's FQ Coddle, which is something that we use very much to enhance the QoE of subscribers and to solve buffer bloat problems. There's PIE was the cable modem standard that's been implemented in a lot of cable modems, again, since the buffer bloat stuff. So some really, really cool things came out of that whole research area. So I think we're still having a couple IT problems getting everybody back in, unfortunately.
Dan, are you able to hear me now?
We will give that a second.
I can hear you, Jeremy.
It's like Dan can't hear us.
Well, maybe I'll jump to one of the slides at the end here, and hopefully we're able to solve the IT problems. So I mentioned FQ Coddle. So I think this is one of the main, this whole renaissance in queue management techniques is one of the main inspirations of why we started Preseem in the first place. And buffer bloat and this whole network area has been a long-term interest for myself. But what FQ Coddle does is kind of layers fair queuing on top of the Coddle algorithm. And by doing that, you isolate traffic from each other so they can't negatively hurt each other, and then run the Coddle algorithm within each one of those individual queues. And by doing this, and you essentially go from that simple first in, first out, every flow fights with each other, adds a lot of latency, to a situation where short flows and isolated flows get very low latency, even if the network's busy. And that's really back to you can run a network at very high rates if you're able to have a good queue management strategy. All right. Jeremy, are you back?
Yes, I am. Can you hear me?
Perfect. Excellent.
Wonderful.
So I've just been going through a few of our slides, waiting for everything the IT problems to sort themselves out. So I was just explaining a little bit of like queue management it's really, I think in my mind, the long-term solution to this. Like 20 years from now, every network device will hopefully have good queue management built in, but that is just not the reality today. And in the meantime, we're kind of back to what we talked about earlier: shape below the bottleneck link, or move the bottleneck link to where you can do something smarter. So go ahead.
Well, one thing that's kind of interesting in the history of the internet is we've always been focused on download, but as people are starting to evolve on how they use the internet, the upload is becoming more and more important. You know, you have people that are, even from just like being able to view security cameras at your home to baby monitors to being able to stream content online. So with that drive to be able to have a more of a quality connection than just raw download, hopefully the vendors will take note and start adding more intelligent buffering into their products.
Mm-hmm. Yep. Great. Okay, so where do we want to go through things from here? I'll jump back to the beginning and our little discussion points. Where do you guys want to kind of go from here?
So we pretty much covered all the points so far. What else? I mean, do you guys have any other experiences? I know I've had a lot of situations where it's most prevalent for me is like a congested access point, and that seems to be where I see it most often. Then again, it's probably where it's the easiest to see it. So, you know, just because you don't see it doesn't mean it's not occurring somewhere. So,
and that kind of flows right back to the discussion we had in the last one of these we did around busy access points and stuff, and people expecting too much from their access points, maybe based on the marketing numbers and stuff, and not really understanding what they need to do. So, or what the access point's actually capable of, and having realistic expectations of it.
So, Jeremy and Dan, what are some things when someone calls complaining of speed? So
does anyone have any questions? We can post them on the side here, and we're happy to go down any other rat holes that anyone's interested in. Although I guess we're actually over a half an hour already.
Dan, can you hear Brandon talk at all?
I cannot hear Brandon talk.
Okay. Well, that's probably why you just. Okay. Well, yeah. When Brandon started talking and you jumped all over him, and it was just like, I'm sorry, I can't hear Brandon at all.
Okay. Well, go ahead, Brandon, and I will be quiet, and hopefully the recording is getting all three of us.
Yeah. Well, I guess my question would be for you and Jeremy would be, how would you diagnose buffer bloat, or how can we help our listeners diagnose buffer bloat so that they know that is the problem that they're seeing?
So Dan, in case you didn't hear that, we're talking about how do you diagnose buffer bloat? Like what are some of your tools and your mechanisms you're going to use to diagnose when this is happening?
Sure. You can take that first if you want.
Sure. Well, obviously the biggest thing you're going to see is increased latency. So that's kind of one of the keys to being able to have metrics that you're collecting on your various pieces of equipment. Whenever you see an increase of latency, you're going to see that. You're also going to have increased customer support calls, especially gamers. Gamers are going to be the ones that and people who are using VoIP over IP. Those are two that are going to see these problems the fastest. Because it's really going to degrade their experience of needing something that's real time.
Mm-hmm.
So the biggest answer is latency and jitter. I mean, either one of those are going to be increased when you're experiencing buffer bloat.
So our monitoring
tell
tools.
me, since again, I'm not sure what's happening to the audio. I can't hear Brandon, so tell me if I'm talking over him. Yeah, and that's really, we've made certainly a big focus on that in our product as well, to measure latency at a very, very fine-grained level from the actual subscriber traffic for exactly that reason, because it really is, it and throughput are, and well, loss too to some extent, but throughput and latency are really the ultimate measures of quality of experience on the network. And too often, as a community, as a networking people, we just focus on throughput.
Absolutely.
Yeah.
Okay. Anything else? I guess we're over a half an hour. We kind of target a half an hour with these things. If anyone has any questions, please drop them into the chat, and we can go down some topics in that direction as well.
Not seeing any questions online yet.
All right. I can't tell if Brandon's talking.
Yeah, Brandon just literally just said he doesn't see any questions in the chat yet. So I didn't think I was going to be a translator today. That's a new role.
That's interesting. I'm going to blame that on some kind of like routing problem inside Big Marker or something, that I can hear you and I can't hear Brandon. I have no idea.
Yeah, that's a strange one. Maybe Brandon's getting some buffer bloat.
Yeah.
Dropping some packets.
Yeah, exactly. Okay, well, great, guys. Sorry, everyone, for weird IT problems, but it seems that every meeting has some form of IT problems in COVID days. At least it seems that way. But if you have any other questions, please let us know. Let us know if you think this is interesting. Suggest other topics if you have any that you would like us to talk about in the future. That would be super useful as well. It looks like we might have one question. The question is, what FQCODL on EdMax would you recommend? So that's probably, you want to take that for a second, Jeremy, and then I can kind of go after that?
Well, one slight problem there. I'm a MikroTik guy. I've actually never used an EdMax router, so I'm not sure if I have a good answer for that one, unfortunately.
All right, so that's why I was kind of passing it to you too. So that's certainly, knowing what to do with that model of hardware is not our thing. What we do though is we give every subscriber a really big FQCODL instance. So we isolate the traffic between subscribers, not just on a single output port. So that's something that requires a decent amount of CPU and stuff, which is why we're appliance versus like a switch or something. But I don't know what the features are of that particular router in terms of whether if you can only do it on an output link, like on a link aggregate basis, that's still better than nothing. But doing it with inside each subscriber's plan is really what makes the quality of experience way better.
I concur.
All right, we'll send a recording out to everyone. The people running the knobs in the background tell me that even though I couldn't hear everybody, everyone else could. So hopefully the recording is going to have all the everything going on and not some of the gaps. And again, if you have any comments or neat things you would like us to talk about in these sessions, please fire them over. When I think, speaking, I guess, a little bit for everybody, I think we're happy to bring on guests too, maybe. Like if there's someone that has some particular expertise that would like to talk about something and we can kind of query them back and forth and make a discussion out of it, I think that'd be fantastic. So, okay. Awesome. All right. Thank you, Jeremy. Thank you, Brandon, even though you can't hear me. And we'll try this again. Thanks, everybody.
Guys.
Yeah. Bye.